Even off-board home chargers should be standardized. Brings in, tomorrow you may change a vehicle, you don't want to keep changing that. Reduces cost, volumes and non-proprietary nature. Now what needs standardization? This is important. Limited standardization so that vehicle can be charged by any charger. That's the only objective. Charger is that any vehicle I should be able to come and charge. So what do I need to do? My connector, if it is not standardized, I can't charge my vehicle. I need a standard connector and cable. So my connector needs to be standardized. It is like if your 230 volt AC that you use at your home and office, if they are proprietary and there are different sockets made, then you won't be able to charge your appliances. You want standardization of the connector. Charging voltage and power limits. You need some standardization there. You can't charge any this thing. For example, it is a 230 volt AC, 5 amperes. In fact, there is another plug for 230 volt, 15 amperes. There are plugs for 440 volt, 3 phase. We often don't use it commonly, but industry uses it. That's also standardized. So charging voltage, power limits. How much power are you going to be able to draw? Because there is a voltage and there is a maximum current. That needs to be standardized. And if a vehicle battery needs higher voltage or power, the charger will not work. So you may have different charger for different voltage and charging power. Generally, if you design something for, let us say, 72 volt, you also design it to work for 48 volt and 60 volts. So lower voltage often is acceptable, higher you design it for that maximum. What is the next standardization? You know, the charger need to talk to energy operator, not just for metering. Of course, how much energy you are drawing, that is a metering, and there may be time of the day metering, time of the use metering. So you may want to communicate what should be the charges, but also how much power am I going to draw. If I am going to draw heavy power, and many of the chargers tomorrow will be 50 kilowatt, small chargers probably do not need that, but large chargers, if I am drawing suddenly 50 kilowatt, I am actually impacting the grid. So the grid must know where all chargers are drawing large amount of power, and therefore a communication protocol with energy operator. Worldwide this has been by and large standardized. Then you need a communication protocol. You need to talk to the vehicle. How much voltage do you need? How much current do I need? Can I feed you more current? Should I give you slower current? Is it going to hurt battery if I give you larger current? Is it that are you getting heated up, and should I not give you as much voltage and current? All that is important to talk. Should I charge very fast? Battery may not be able to take it. Battery and charger needs to talk, and I am kind of putting battery and vehicle together because battery is in a vehicle. Communication protocol between the charger and vehicle therefore is very important. Protection and safety is very important. If suppose something goes wrong, too much current can come. Batteries are risky, dangerous. You need to cut off. Protection and safety, that also requires some communication. So this are the thing that needs to be standardized: connector, charging voltage, power, communication protocol with vehicle, protection and safety. That is all that is required. Other things need not be standardized. One can specify sometime maximum efficiency, power factor, size and weight, but let market decide these things. Somebody has larger charger, well, somebody has lower efficiency, lower power factor, they are wasting energy. Market will sort of soon find the one which are more optimum. So that is need not be standardized immediately. What are the standardization effort in the world? Basically, there are three primary standardization efforts. Japan started it because they started with electric vehicle. They came up with a concept called CHAdeMO. Their standard is called CHAdeMO. And CHAdeMO in Japanese actually means let us go for a cup of tea. This was because when you came and parked the vehicle and started charging, it will take long time, at least an hour, maybe more. Say, okay, let's go for a cup of tea. So it's called CHAdeMO. DC chargers were standardized. China followed its own standardization called GB by T. It came later than CHAdeMO and therefore it has many more features. It's a more advanced. CHAdeMO is trying to catch up, but GBT charger is slightly more advanced. Europe came even later and proposed new EV charger standard, initially a CCS and now it is a CCS2. That is the most advanced. And it also introduced what is called from battery to grid to battery and battery to grid. From here I said grid to battery, actually they have also incorporated battery to grid. Now basically if your vehicle battery is full and your grid is short of power, it can draw back the power. So that is also came in. USA came in very late. They were initially opposing, the big oil lobby opposing, and then they adopted a mixture of Japanese and Chinese standard. Basically there are three standards very commonly known. Level 1, it is a AC charger of the grid. It is a simple, pretty much the kind of plug that is put is very similar to the home plug. I will say not home 5 ampere plug, 15 ampere plug, the kind of thing that you use for air conditioning or things like that. Level 2 AC charge, level 1 had no communication. Level 2 was a AC charger, but its communication to the vehicle, but did not specify communication to the grid. Level 3 chargers are generally high power, generally DC charger, though there is a AC option also, and they have both communication to the vehicle and to the grid. Okay. So there are three kinds of charger: level 1, level 2, level 3. All chargers use the same standard between the charger and the grid, that is OCPP. It is standardized. Between the vehicle and charger they vary. CHAdeMO is different, China is different, Europe is different. Standardization in India, India started looking in only in 2017 and they started looking at affordability rightly, that everything has to be affordable, because in India affordability is a very, very big issue. And they specify two chargers. One is, they call it a Bharat chargers, AC001. This was less than 3 kilowatt AC charger, no communication to the grid or to the vehicle. It's a kind of a level 1 charger. Remember that this charger is 15 ampere 230 volt, same as what is used by air conditioner and washing machine at homes. Of course, it used an industrial plug, so that many times taking out, taking on, putting in will not hurt. It is a very simple charger, up to 3 kilowatts it can give you. This should have been adopted and used, it has been adopted, but politics goes on. Then there is a DC001 charger, that is the first DC charger. This was specified 48 volt for small 2-wheelers and 3-wheelers, because they use 48 volt, 15 kilowatt. 15 kilowatt is a lot for small vehicles, and it could also be done at 60 volts or 72 volts DC charger. It uses OCPP communication to the grid, and it uses DC001 based on the GBT protocol that China used for communication with the vehicle. Some modification was there. We thought that we could standardize this and just win the market. Unfortunately, governments and industry do not fully agree. We also said that well, AC002 and DC002 could be defined. AC002 would have been level 2, level 3, level 2 AC charger, and DC002 will be not 15 kilowatt, but maybe 50 kilowatt or 100 kilowatt. But that committee kind of got dissolved and did not do things. So, India needs to move rapidly. They could easily take AC001 or AC001-1. What is the difference? AC001 is specified a charger which could charge 3 vehicles together. AC001-1 is a single charger version of AC001 defined by Department of Heavy Industry. Up to 3 kilowatts onboard charger could be done, and time of day metering was incorporated. Define AC002 as a first level, as a level 2 fast AC charger, and we could change the connector, etc., and power between 3.7 kilowatt to 22 kilowatt. This could have been done very quickly and can be done, except people who do not understand technology, do not understand economics, sit in the government. One could have defined a AC003 charger which could have been even greater than 22 kilowatts. One could have defined DC002. I would have thought that CCS2 would be the best standard, which could be 50 kilowatt or 100 kilowatt, and DC003 could also incorporate vehicle to grid. This was the plan that was made, which could have been done, being done, but in a very poor manner. Bulk charger and swappable battery standardization. We will go on with swappable battery as standardization. Standardization of lock smart protocol, that will help, it can't be stolen, and every operator will have a different key. So, it is not that somebody's battery will be used by somebody else. Standardize the voltage for each vehicle class. For 2-wheeler you could do 48 volt, or large 2-wheeler you can do 72 volts. For 3 e-rickshaws 48 volt, auto 48 volt. For 4-wheeler you can define 350 volts. So, operating voltage needs to be standardized and they will be different. Connector needs to be standardized. Protocol for communication to vehicle and protocol for communication to charger. This is what is required. Oh, communication to vehicle and charger is same. What I meant was grid, make that correction. One was communication to grid and communication to charger. One can also specify maximum battery size, so that a maximum battery size, if it fits into your this thing, smaller battery size can always fit in. Bulk charger standard, only the connector and protocols for communication with battery need standardization. That is all, nothing else needs standardization. So, that is the end of chapter 4. We will now do a very small short chapter on board charger 7.5. This is a charger which is purchased with the vehicle and will stay with the vehicle. Wherever you go, you just plug it in and it will charge. So, basically AC to DC conversion is done on the onboard charger, and this DC conversion can be, this charger can be inside the car, fitted in the car, or could be portable, it does not matter. Dedicated to specific vehicle, generally tend to be proprietary. Chargers are specified battery voltage and voltage range. Voltage range, because the battery, when it is 0% SOC to 100% SOC, you will see that the battery will have to take different voltage. Maximum current for charging. Efficiency and power factor, that will be important, because when you are buying a vehicle, you do not want to waste energy. And of course, environmental and safety, EMI, AMC, IP rating, etc. will specify the onboard charger. Onboard charger do not normally have communication to grid or to vehicle. Also, if it is a onboard charger, it normally does not even have metering. New generation smart chargers have communications to battery to monitor temperature and decrease current to preserve battery life, also communication to management server for battery monitoring. So, there are possibilities, but that is what currently is. There are two modes of charging, as I pointed out, constant current and constant voltage. You start in a constant current. The vehicle will tell charge at this current, and a feedback loop adjusts the voltage to maintain such that a constant current comes out. So, you will keep on decreasing voltage, so that this comes out. The second part, you charge it to 70%, 80%, depending on the rate at you are charging, sometimes 85%. Then you get into constant voltage. Now, you cannot push in that much current, because the upper limit of the voltage is getting reached. Now, you clamp the voltage, constant voltage, and reduce the current. This is a constant current till the current becomes 0, in which case it is full. CV mode is when battery is nearly full, energy input the battery is only a few percent. Different vehicles with same battery voltage could use same onboard charger. Now, this is a big advantage. I do not need multiple kind of charger. Needs charger to have adjustable value for constant current and constant voltage. Preferably, the adjustment can be made using software communication between battery and them. One can adjust constant current in CC mode, control charging rate, and preserve battery life. Chargers are power electronics. Chargers with poor efficiency and low power factor are inexpensive, but it will be wasting power. In the long term, they turn out to be expensive. Advances in power electronics have made these chargers efficient with power factor correction, small in size and low weight in recent years. AC power after rectification is converted to high frequency signal. So, this is the mechanism. You convert it to high frequency signal, very high frequency, could be 10 kilohertz, 15 kilohertz. Small high frequency transformers are used to then reduce increased voltage level to the desired level, and then rectification is carried out to the desired DC voltage. The control is entirely software. A lot of the charger design is now software. This is as far as the onboard charger is concerned. The next chapter is going to be bigger and public chargers.